Variance. The variance in cell E8 is calculated using the formula equals var.s open parenthesis B2 colon B13 close parenthesis. Excel calculates the variance of the sample of 12 home sales. Standard deviation. The sample standard deviation in cell E9 is calculated using the formula equals ST DEV.S open parenthesis B2 colon B13. Excel calculated the sample standard deviation for the home sales to be 95,065.77. Coefficient of variation. It is calculated in cell E11 using the formula equals E9 over E2, which divides the standard deviation by the mean. The coefficient of variation for the home sales data is 43.22%. Measures of variability. The standard deviation is the positive square root of the variance, measured in the same units as the original data. For sample, S equals square root of S squared. For population, this is our formula. The coefficient of variation is the standard deviation divided by mean times 100 in percent. It measures standard deviation relative to the mean and expressed as a percentage. Computation of coefficient of variation. Example, consider the class size, data, 46, 54, 42, 46, and 32. The mean is 44. The standard deviation, S, is 8. The coefficient of variation is 8 divided by the mean 44 times 100% equals 18.2%. The coefficient of variation tells that the sample standard deviation is 18.2% of the value of the sample mean. Analyzing distributions, including percentiles, quartiles, z-scores, empirical rule, identifying outliers, and box plots. Percentiles. The value of a variable at which a specified approximate percentage of observations are below that value. The pth percentile tells us the point in the data where approximately p% of the observations have values less than the pth percentile. Approximately 100 minus p% of the observations have values greater than the pth percentile. Steps to calculate the pth percentile. Arrange the data in ascending order, smallest to largest value. Compute k equals n plus 1 times p. Divide k into its integer component I and its decimal component d. If d is equal 0, find the kth largest value in the dataset. This is the pth percentile. If d is greater than 0, the percentile is between the values in positions I and I plus 1 in the sorted data. To find this percentile, we must interpolate between these two values. Calculate the difference between the values in positions I and I plus 1 in the sorted data set. We define this difference between the two values as m. Multiply this difference by d. T equals m times d. To find the pth percentile, add t to the value in position I of the sorted data. Example, to determine the 85 or 85th percentile for the home sales data, in table 2.9, arrange the data in ascending order, and we have the following. Number 2, compute k equals n plus 1 times p. Then we'll have n is 12 plus 1 times the p is 0.85. Then that is equals to 11.05. Number 3, dividing 11.05 into the integer and decimal components, which gives us I equals 11 and D equals 0.05. So D here is greater than 0. Interpolate between the values in the 11th and 12th positions in the sorted data. To determine the 85th or 85th percentile for the home sales data in table 2.9, the value in the 11th position is 298,000. The value in the 12th position is 456,250. Then M is equals to 456,250 minus 298,000. That is equals 258,250. Then T equals M times D equals 158,250 times 0.05 equals 7,912.5. The pth percentile is equals to 298,000 plus 7,912.5 equals 305,912.5. Then the $305,912.50 represents the 85th percentile of the home sales data. Quartiles. When the data is divided into 4 equal parts, each part contains approximately 25% of the observations. Division points are referred to as quartiles. Q1 is the first quartile or 25th percentile. Q2 is the second quartile or 50th percentile. Also, it's the median. Q3 is the third quartile or 75th percentile. Z-score can be interpreted as the number of standard deviations. It measures the relative location of a value in the dataset. It helps to determine how far a particular value is from the mean relative to the dataset standard deviation. Standardized value: if x1, x2 to xn is a sample of n observations, then we have the z-score formula. Table 2.13 shows the z-scores for the class size data. For class size data with the mean equals to 44 and standard deviation equals to 8, for observations with the value greater than the mean, then the z-score is greater than 0. For observations with the value less than mean, then the z-score is less than 0. So in this table, we have the first column is the number of students in class, represented by X. Second column, we have the deviation about the mean. The third column is the z-score. Z1 equals 0.25 would indicate that X1 is 0.25 standard deviations greater than the sample mean. Z3, which is equals to negative 0.25, it would indicate that x3 is 0.25 standard deviations less than the sample mean. This figure shows how to calculate z-scores for the home sales data in Excel. Empirical rule. For data having bell-shaped distribution, within one standard deviation, approximately 68% of the data values. Within two standard deviations, there's approximately 95% of the data values. Within three standard deviations, almost all the values. Identifying outliers. Outliers are extreme values in the dataset. It can be identified using standardized values or z-scores. Any data value with a z-score less than -3 or greater than +3 is an outlier. Empirical rule. The height of adult males in the United States has a bell-shaped distribution with a mean of approximately 69.5 inches and standard deviation of approximately 3 inches. Using the empirical rule, the following conclusions can be drawn. Approximately 68% of adult males in the United States have heights between 69.5 minus 3 equals 66.5 and 69.5 plus 3 equals 72.5 inches. Approximately 95% of adult males in the United States have heights between 63.5 and 75.5 inches. Almost all adult males in the United States have heights between 60.5 and 78.5 inches. An outlier may be a data value that has been incorrectly recorded. If so, it can be corrected before further analysis. It may also be from an observation that doesn't belong to the population we are studying and was incorrectly included in the dataset. If so, it can be removed. It may be an unusual data value that has been recorded correctly and is a member of the population we are studying. In such cases, the observation should remain.